Assalamualaikum, esteemed professor, respected colleagues, and fellow presenters. I am here to present a paper on behalf of my research mate. The title of the paper is The Application of Machine Learning in Detecting Damaged Structures. Before I proceed with my presentation, let me introduce you my fellow researchers who have been working extremely hard to make this study a success. The esteemed researchers are me, Farah Farzana Abdul Aziz, Associate Professor T.S. Dr. Zahra Yahya, Associate Professor Dr. Dewi Izwi Abdul Manan, and Associate Professor IR Dr. Muhammad Azmi Yunus. I will start the presentation by giving the background of the study in the introduction. I will then review a few previous studies, then I will talk about machine learning and the proposed method for the study. Lastly, I will conclude the presentation with some concluding remarks. It is very important to note that the reduction in stiffness caused by fractures and other damage substantially impacts the performance, safety, and dynamical characteristics of civil, mechanical, and aeronautical structure. Hence, early detection of damage in the structure is crucial to prevent further problems. However, due to uncertainty of the damage in nature, the damage in the structure is challenging to predict correctly, either numerically or experimentally. In a normal practice, the visual inspection are carried out in order to identify the presence of damage to the structure. Smith in 2018 said, since the size and complexity of the structures increased, the manual approaches to detect them might not be accurate and doubtful. The practicality and reliability of current manual approaches are at risk of human errors. Due to the computer technology advancement in sensor technology, artificial intelligence such as machine learning have attracted much attention in engineering application for damage detection. Therefore, this paper seeks to propose an advanced AI-based solution, which is machine learning, using artificial neural network and model testing unit. Moving on to the next part of this presentation, we shall see what previous studies have discovered. Structural damage can result from various factors, and advanced monitoring methods like structural head monitoring and structural damage detection have developed rapidly due to real-time sensors. Vibration-based techniques assess damaged structures and enable corrective action to prevent further harm. SDD, as shown in Figure 1, is widely used in engineering fields and employs systematic automated processes, including data collection and pattern recognition. This system consists of hardware components like sensors and data interface. However, practical challenges include time-consuming inspection and the need for skilled workers. Figure 2 illustrates the concept of machine learning system, which can automatically learn and improve from experience without explicit programming, thus enhancing their capabilities. In vibration-based structural damage detection methods, machine learning tools like artificial neural networks, support vector machine, self-organizing maps, and convolutional neural network are applied to develop parametric and non-parametric SDD systems for structures. Figure 3 represents the application of this trained machine learning system, where they are used to classify and identify the presence and location of structural damage. These involve common tasks in ML-based SDD, including feature extraction and training. These advancements in machine learning contribute to more efficient and automated structural damage detection processes. These advancements in machine learning contributes to more efficient and automated structural damage detection processes. Machine learning algorithms are categorized into two main types, which are supervised and unsupervised. Supervised algorithms, as depicted in Figure 3, rely on human-labeled data for training, seeking the best mapping between input and desired output. This means a human supervisor assigns correct labels to data samples before training. In contrast, unsupervised learning algorithms work with unlabeled input data to uncover underlying data patterns without specific labeling. Recent research found that machine learning is better than traditional methods, especially when there is noise in the data. To detect structural damage, they use accelerometers placed strategically on a building and unique algorithm to translate the vibration into damage indicators. They propose using machine learning and artificial neural network to predict damage by looking at how structural properties affect vibration. They train A and N using finite element results to connect damage severity with changes in natural frequencies as shown in Figure 4. This method can be applied to other structures after verifying its effectiveness on a large-scale one. A simplified model of an aerospace component representing a part of the aircraft fuselage was used, and its finite element model was divided into elements. Structural joints with bolt connection were modeled using CWAR elements connectors, with the choice of connected elements being crucial for accurate vibration prediction. The integrity and dynamic characteristic of the structure rely heavily on these joints. Detecting damage early is vital because incorrect bolt tightening during assembly can harm the structure integrities and change its dynamic properties. This paper proposed a vibration-based damage detection method using machine learning and artificial neural network to identify damage in bolt joints. The goal is to refine the initial finite element models for undamaged and damaged structures to match measured data as illustrated in Figure 5. To validate the approach, these models' natural frequencies and mode shapes are compared with experimental data. Now we have come to the end of the presentation. It is worth to note that the investigation of dynamic behavior will be conducted, whereas in the numerical section, SIBA was implemented as a structural joint. The bolt joint structure will be measured by using engineering method analysis. Finally, the optimization of machine learning and artificial neural networks are proposed. Here are the lists of reference, and I thank you for your kind attention.